Welcome to our A-Level Physics Paper 1 review session. I'm Ian, and I'll be your host and teacher for today. Joining me is Anna, who will be answering the questions and might need some assistance with a few of them. Let's jump right into it and tackle some high-mark questions from the exams between 2018 and 2021. Let's begin with question 1. Describe the difference between elastic and inelastic collisions. 6 marks.
In an elastic collision, both momentum and kinetic energy are conserved, meaning the total momentum and kinetic energy before the collision equals the total momentum and kinetic energy after the collision. In contrast, an inelastic collision only conserves momentum, while kinetic energy is not conserved, as some energy is lost to heat, deformation, or other non-conservative forces.
Excellent answer, Anna. Now question 2, 2019. Explain how Newton's laws of motion can be applied to a rocket launch. 6 marks.
Newton's first law states that an object at rest stays at rest and an object in motion stays in motion unless acted upon by an unbalanced force. Initially, the rocket is at rest on the launch pad. When the engines are fired, they generate thrust and unbalanced force, which propels the rocket upward. Newton's second law states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. As the thrust force exceeds the rocket's weight, the rocket accelerates upward. As the rocket burns fuel, its mass decreases, and its acceleration increases due to the constant thrust force. Newton's third law states that for every action, there is an equal and opposite reaction. In the case of a rocket launch, the rocket exerts a downward force on the exhaust gases, and the gases exert an equal and opposite force on the rocket, pushing it upward.
Great job, Anna. You've covered all 3 laws nicely. Question 3, 2020. Describe the energy transformations that occur in a hydroelectric power plant. 6 marks.
In a hydroelectric power plant, potential energy stored in elevated water is converted into kinetic energy as the water flows downhill. The flowing water spins a turbine, converting kinetic energy into rotational kinetic energy. The turbine is connected to a generator, which converts the rotational kinetic energy into electrical energy. This electrical energy is then transmitted through power lines to consumers.
Well done, Anna. You've explained the process very clearly. Next one, question for 2021. Ian, explain the difference between speed and velocity. 6 marks.
Speed is a scalar quantity that measures how quickly an object is moving, regardless of its direction. Velocity, on the other hand, is a vector quantity that takes into account both the speed and the direction of an object's motion. In mathematical terms, speed is the rate of change of distance traveled per unit of time, while velocity is the rate of change of displacement per unit of time. Displacement accounts for both the distance traveled and the direction of motion.
Great answer, Anna. You've clearly distinguished between the 2 concepts. Next on to question 5. Describe how the phenomenon of diffraction can be observed in the double-slit experiment. 6 marks.
In the double-slit experiment, a coherent light source is passed through 2 narrow slits, forming an interference pattern on a screen behind the slits. As light passes through each slit, it diffracts, or spreads out, causing the light waves from each slit to overlap and interfere with each other. This interference results in alternating regions of constructive and destructive interference on the screen, producing bright and dark fringes, respectively. The diffraction of light through the slits is crucial for the formation of this interference pattern.
Excellent explanation, Anna. You've described the role of diffraction in the double-slit experiment very well. Question 6, 2019. Now, explain the difference between transverse and longitudinal waves, providing examples for each. 6 marks.
Transverse waves are waves where the particles of the medium vibrate perpendicular to the direction of wave propagation. An example of a transverse wave is a wave on a string or a wave in a rope. The string or rope moves up and down while the wave travels along the length of the string or rope. Longitudinal waves, on the other hand, are waves where the particles of the medium vibrate parallel to the direction of wave propagation. An example of a longitudinal wave is a sound wave in air. Air particles vibrate back and forth in the same direction as the wave travels.
Great job, Anna. You've provided clear examples for both types of waves. Now for question 7, 2020. Ian, explain the role of magnetic fields in electric motors and generators. 6 marks.
In electric motors, A current-carrying coil is placed within a magnetic field. The magnetic field exerts a force on the current-carrying coil, causing it to rotate. This force is due to the interaction between the magnetic field and the magnetic field produced by the current in the coil. This rotation is used to perform mechanical work, such as powering a machine or driving a vehicle. In generators, the process is reversed. Mechanical energy is used to rotate a coil within a magnetic field. As the coil rotates, a changing magnetic flux through the coil induces a current, converting mechanical energy into electrical energy. This current can then be used to power electrical devices.
You described the roles of magnetic fields in both electric motors and generators very well. Question 82021. Ian, describe the phenomenon of refraction and explain why it occurs. 6 marks.
Refraction is the change in direction of a wave as it passes from one medium to another. It occurs because the speed of the wave changes when it enters a different medium, causing the wave to bend. Refraction is observed when light passes from one transparent medium to another, such as from air to water or glass. The change in speed of light in different media is due to the change in density, which affects the interaction of light with the particles in the medium. As a result, the direction of light changes as it enters the new medium, causing the apparent bending of light.
Excellent explanation. You've covered the key aspects of refraction very clearly. Question 92018. Ian, explain how transformers are used in the transmission of electrical energy. 6 marks.
Transformers are used in the transmission of electrical energy because they can increase or decrease the voltage of an alternating current. This is important because transmitting electrical energy at high voltages reduces energy loss during transmission. In a step-up transformer, the number of turns in the secondary coil is greater than the number of turns in the primary coil. This results in a higher voltage in the secondary coil, allowing for efficient long-distance transmission of electrical energy. At the receiving end, a step-down transformer is used, where the number of turns in the secondary coil is less than the number of turns in the primary coil. This decreases the voltage, making it safe for use in homes and businesses.
Great job! You've described the role of transformers in electrical energy transmission clearly and concisely. Question 102019, Q4, 2. Ian, describe the greenhouse effect and explain how it contributes to global warming. 6 marks.
The greenhouse effect is a natural process that keeps the Earth's surface warm enough for life to exist. It occurs when gases in the atmosphere, such as water vapor, carbon dioxide, and methane, absorb and re-emit infrared radiation from the Earth's surface, trapping heat and maintaining a comfortable temperature. However, human activities like burning fossil fuels and deforestation have increased the concentration of greenhouse gases in the atmosphere. This has led to an enhanced greenhouse effect, where more heat is trapped, causing the Earth's temperature to rise above normal levels. This temperature rise is known as global warming and can lead to various environmental problems, such as melting glaciers, rising sea levels, and more extreme weather events.
Well done, Anna. Your answer demonstrates a good understanding of the greenhouse effect and its impact on global warming. That concludes our AQA Level Physics Paper 1 walkthrough. Thank you for joining us today, Anna, and we hope our discussion has been helpful for students preparing for their exams.